For hundreds of years, people have been knitting with knitting needles. Since then, the technology and tools haven't changed much at all. That is, until today.
It was high time to invent something new and not simply to duplicate materials. We therefore followed the principle of form follows function and invented a needle which addresses the problem every knitter has. In other words, the form of our new needle is different. It starts with a drop-shaped tip, is then round, and finally triangular. This guarantees that the stitch slides easily along the needle.
At the other end, we have a thin steel cord. Most needles today have a plastic cord. This plastic cord has a so-called memory effect. The plastic is strengthened with glass fiber. Depending on the gauge of the needle, we have found the optimal mix of plastic strengthened with glass fiber. That means high bending strength but also flexibility. Thus, our needles are not completely rigid like steel needles, but are slightly flexible. You can even tweak the needles and thus knit faster.
However, the industrial production of needles like this requires a complex production process. A new production facility had to be specially developed. Therefore, the producers of these needles got in contact with the Steinbeis Research Center for Automation in Lightweight Processes in Chemnitz. Professor Nendl and Mirko Spieler and their team received the task of changing the former manual production process to a fully automated one.
The special challenge we faced in this project was the task of combining the complex material mix in a fully automated process and at the same time combining different production technologies. The cord is delivered in reels. It is wound off, straightened and then cut to length. Then it is transported to the workpiece carrier, which is an injection molding tool, the cavity. After the molding tool is closed, a robot passes the whole thing to the injection molding machine.
The high-performance plastics are cast around the thin metal cords, using spraying pressures of between 800 and 1000 bar. At the end of the process, the tool is taken out of the injection molding and sent to the printer. A logo and type characteristics are printed on the needles, and the finished needles are removed from the facility. At the Steinbeis Research Center in Chemnitz, this complex automated facility took only 1 year to develop, design, and build.
The smallest needle is 2.5 millimeters. The cord is 1 millimeter thick. In other words, you have a coating thickness of 0.75 millimeters, which holds the cord in the middle.
And what do the customers say?
The market is thrilled and the response has exceeded our expectations. The needle has been very well received, even the fact that the needle has a drop-shaped tip, which we feared would be the biggest handicap. You might think that this would be a hindrance, but in actual fact, this is the part of the needle which is especially praised by beginners and experienced knitters alike. By beginners who don't drop their stitches so often, as well as by experienced knitters and fast knitters who say, "Wow, I'm so much faster than before."
Schnellstrickern, die sagen, "Boah, ich bin mit dem Teil noch schneller unterwegs."
With this good response in mind, we are considering the next step. What do we have in the pipeline? We have a number of ideas which we are discussing with our partners at the moment. We are also thinking about extending our market to other regions. At the moment we sell our needles only in Europe. Prim is active worldwide, and as soon as we have the production capacity, we will open up those markets. The motivation behind a project like this is always to find an answer to complex technical problems. And the most satisfying thing for an engineer is when he succeeds in finding a solution. And it is even better when the results obtained from basic research can be put into practice.